Welcome back to the Integrate Intelligently podcast. I'm your host, Jeff Brickler. Today is a special day, more than usual. Again, I'm accompanied by CEO and founder of CADTALK Software, Scott Brickler. And today is the Engineering and Manufacturing Revolution. We have a special guest with PBC Linear. We're going to talk about their journey to automated excellence. So welcome, Jonathan and Ethan and Scott. Welcome to the podcast.
Thank you.
Thank you.
Good. So let me give a little introduction. I mean, Ethan and I know each other for, I don't know how many years now.
A couple of years now.
Been a minute. Yes. I think my beard is grayer. I'm balder. Not balder, no, but beard is grayer for sure. So, and Jonathan, it's nice to meet you. I'm not sure if we've spoken much, but good to meet you. I'm sure you've worked with Ethan for quite some time. So I want to talk few years. Yeah. Like me, right? Like a few years. So would love to hear a little bit about, I think just an introduction about, PBC Linear, what the business does, what kind of products you have, what kind of setup you have, that sort of thing. Just lay the groundwork for folks in terms of what you're doing and, kind of how you met us and that sort of thing. So maybe that'd be useful as a start.
Yeah, sure. So PBC Linear has been in business since 1982. Originally, business was called Pacific Bearing Company, and now we did a name change around 2008 to be doing business as PBC Linear. When the business was founded in the early 80s, the Midwest was going through a recession. Illinois, or Rockford, Illinois, where we are founded, had a 26% unemployment rate. It was the highest in the nation for 3 out of the 4 months of the year. And the remaining 9 months, there's some plant in Michigan or Ohio or somewhere. One of the big 3 automakers shut down a plant and just destroyed a town. Their unemployment is 40%. But anyways, the Rust Belt was not doing well. But California, the Pacific Ocean area, was doing outstanding. So we named ourselves Pacific Bearing to lead Americans to believe that we were located out in California and therefore much more stable. Well, fast forward to the 2000s and we become a much more global nation. And a lot of our competitors are importing product from China and doesn't have a very good reliability. And it's not known for that reliability. So then we also expanded our product portfolio and went from making individual bearings to more linear motion products, solutions, actuators, assemblies, full-blown systems, do some contract assembling, lots of additional things. So we went ahead and adjusted our name to be PBC Linear to better match everything that we're doing. And today we make individual bearings, we make linear slides, linear motion components, we make full-blown actuators, and then we do full-blown custom assemblies. We have 225-ish thousand square feet of manufacturing space in Northern Illinois. We have a wholly owned subsidiary in Germany that serves the European and EMEA markets. And then we have a joint venture with the largest stepper motor manufacturer in China.
Wow. So tell me a little bit about so every company, Scott would know, starting one, and I think every company, the founder has a vision, right? The reason you start a company is you have a vision of something you're trying to achieve, right? What am I trying to do here? And why can I do it better than everyone else, right? Why should I start the company? So can you talk a little bit about that vision and maybe the values? I think you touched on it a little bit, but that vision for what I think it says here that your father created, or your father had this idea?
Yeah. So my dad and grandfather started the business in the early 80s, late 70s. They were running a machine shop for a group of investors, and then they took it over. And then pretty much right after that, there was a giant recession. Our contract business was primarily servicing John Deere, International Harvester, and a number of those types of companies, and they all went on strike. And our business went from very profitable, a great business, a great investment, to they maybe wish they wouldn't have done that, because everything rolled up and dried up overnight. So coming out of that, my dad and grandfather decided that we had to have standard products to sell. not just contract parts that we were making for companies, which, by the way, 45 years later, we're still making some of those exact same parts for some of those exact same customers. But we needed a standard type of product. So they invented the simplicity bearing. And then unfortunately, just a few years after that, my grandfather had a bunch of heart attacks kind of back to back. And his doctor and his wife decided to force him into retirement. And then it was pretty much my dad from there on out. I joined the business technically I got my first paycheck when I was 10, working in our factory. That's kind of frowned on now. I'm told I can't put my kid to work in our factory anymore. But I started when I was young, and then I joined the company full time after college, and then left for a few years to go work for Fortune 500, and then came back about a little over a decade ago.
Okay.
So in our journey, is fairly diverse. So one of the things that makes us unique is we are one of the largest still privately owned linear motion companies in the world. And we make a diverse range of products that go across different categories. So in our industry, there's different types of bearings. And typically what you'll find is companies make one type of product or another. We make actually products across multiple categories. And that's because after that initial trouble that my dad and grandfather had early in the business, very early in the years of the business, we decided that we did not want to be a slave to any one industry. We did not want any one single customer to represent more than 20% of our overall business, because we did not want to have an issue if a particular industry went down or a particular customer went down. So like if we go back and look at the last couple of recessions that we've had, COVID, and then the last recession before that, our business fared better than average because we serve medical applications, which that's always going to do well. When the housing bubble burst, we only have a small number of business tied to that industry. When automotive shifts up and down, one of the only two applications that we don't sell into is automotive. We don't sell any parts that go onto cars. We sell parts that make cars, equipment that make cars, but not into the cars themselves. So we're not tied to the volatility of that industry. The only other thing we don't sell is for insurance reasons. We choose not to live with liability of selling flight critical systems for commercial airplanes. We sell to companies that make business class seats and sliding tray tables and pocket doors and all kinds of other parts on the plane, just nothing that's considered flight critical. From a diversity standpoint, we have bearings that are in outer space. We have bearings that have gone to the bottom of the ocean. We have parts that are used in clean rooms. We have parts that are used in foundries. So basically the cleanest application on Earth to the dirtiest application on Earth to the bottom of the ocean to outer space, our bearings are used pretty much everywhere in between.
That's incredible. Yeah, that's really incredible. I'm always amazed at about the supply chain and how like PBC Linear, like it's important, right? But you guys don't make a bunch of different things. You specialize really in what you do, but you do it world class. So I always find that really interesting. Talking to manufacturing companies, right? That specialization.
Right. And, just for your listeners that may not be familiar with our company, most of your listeners probably are familiar with an airport. They've been through the airport. And just kind of an example, we do some really high-end, very precision applications, and we do some more lower-end applications. So in an airport, they've probably passed by one of those Pepsi machines where the little robot goes up and grabs it and brings it over and drops it sideways through a little thing. Our company did the design of the current generation, maybe now it's a former generation of that machine.
Cool.
And then there's other equipment there, like higher end automated retail, like the Best Buy kiosk, the cosmetic kiosk, where they've got typically like a conveyor belt that will go up and down. Product will be dispensed and then go down and move over. That's basically a 2-axis robot. And you'll typically find our products on that 2-axis robot.
Yeah, that makes. I used to come from the packaging industry, Jonathan, years ago before I started a company called R.A. Jones that made packaging. I think they're probably a customer of you guys. They used to make the machines that put the bags of cereal in the cartons and the bottles of Budweiser in the bags. And then we used to use a lot of linear actuators and bearings and stuff. So probably our customer of you guys, I believe. Yeah.
Probably.
Yeah.
We have these little red bearing stress reliever samples that are probably on most engineers' desks, throughout the U.S. and in Europe they're blue, and in Japan they're green. But yeah, a lot of companies out there, a lot of engineers are familiar with our company.
I wouldn't doubt it. Yeah, that's pretty cool.
Yeah, what I always liked when I talking to manufacturing companies like PBC Linear is like in your industry, like the consumer, which is like people like me or just like regular people, don't know you really exist, right? You're part of that, but it's critical. Like they interact with your products and everything every day, but it's not like the big name brand manufacturers like Ford or that sort of thing. But like all those second and third level companies that in the manufacturing process do know you.
Yeah, like the engineers at Ford will definitely know us
Right.
because our products are used on the assembly line. And speaking of that too, like during COVID, I remember being in our factory right when the governor of Illinois announced that they were shutting everything down, and a couple of days later, the health inspector or somebody comes to our factory and tells us that we have to shut down, and we basically told them no. We had at that time we still do, we had some time sensitive government contracts that parts had to get made for. Like, you go tell the military and the DoD that they're not going to get their parts. They told us if we don't deliver them, guys with machine guns are going to show up and make us make the parts. But you go have that conversation. Oh, and by the way, all the centrifuge equipment and the automated stuff that you guys are using to test COVID, yeah, those ride on our bearings.
Yeah, we're critical in making those.
Yeah. So if you want all that equipment, then we should stay open so you can buy more of that equipment.
Yeah.
And then when they were splitting when things got really scary, and when they were splitting respirators, we have a subsidiary, something like a subsidiary, the company that makes 3D printers, and we were making parts to split the respirators. And so we were definitely a critical business that stayed open through COVID. We did all the things to protect our employees. Anybody that could work from home, we did that from work from home, all that kind of stuff. By the end of the day, like a lot of other manufacturers, somebody's got to be there to push the button on the machine.
I mean, it's truly the definition of a critical business. It's like a lot of times people just do not understand how the supply chain works, and that all of these things are tied together. And then like you can't just close down sections of them and have no effect. I mean, there's downstream effects of all of that. We actually had a podcast that we did a couple of weeks ago about the supply chain, talking about how one electronic chip basically kept all these trucks from being shipped out of Cincinnati, where we're at, because they were missing one chip to plug into the trucks for them to drive off. So there was like literally a racetrack full of trucks just waiting to have a chip for it. And because I think what happened was because they got the chip manufacturer got shut down during COVID. was the problem. So it was exactly the same type of scenario. So it's kind of funny.
Yeah. And like a lot of that comes from China, and, because of our subsidiary over there, we maybe have a little better understanding of how some of that works. Government didn't care if you were a necessary company or not. They shut you down. Right. And they were shut down. So yeah, a lot of that happened over there. And then those silicone refineries, they don't turn back on. A giant furnace doesn't get back up to temperature.
Takes a bit. Yeah.
Like a nuclear reactor, you can't turn those off.
Yeah.
Yeah.
Well, you can, but there are effects. Yeah.
Yeah.
Maybe not a good idea. Yeah. So
I think we digress a bit.
A little bit. Yeah. A little bit. So no, this is good. So I wanted to learn a bit more, like Ethan, get you in a conversation about really engineering, because at the end of the day, right, like your engineers design products, those actuators, and you sell to all over the world. So talk a little bit about what kind of your engineering challenges, how you came to us, what was kind of that light bulb moment.
So a little history there. I actually started at the company 11 years ago, and it was because of the dream of Bob, our owner. He wanted all of the bearings that get engineered by the engineering department and sent out to the shop floor to happen automatically. That little red bearing that I talked about has about 120,000 combinations of it, whether it's size, color, O-rings, mounting options, lubrication, all of these different features. Every time you add a new feature, it just exponentially grows larger. So at the time when I got hired in, the ask was really simple, and I've come to find out the simpler the ask, the harder the challenge is to solve. But the ask was, I want a simple interface for an engineer to go to be able to configure this product. All right, that sounds pretty simple. I think we can do it. It took about 6 years worth of work to really get it off the ground and to the point where the entire factory was using it. But it's at the point now to where any of our products can go through our configurator, get configured, get the engineered correct models and prints. So the models look like and act like an engineer actually created them, along with the production prints and the inspection sheets, and they get sent out to the shop floor within about 10 minutes of the configurator running. So all of that is just years worth of putting different puzzle pieces in place to get this done. So we're using Infor CPQ as our kind of configurator software, and it's great because it handles the front end, it handles a lot of the back end and some of the work there to create the models. But there was a missing link to actually get it from our engineered model state into our ERP system and then out to the shop floor. And that's where just a random email had come out about CADTALK and its capabilities to push SolidWorks information from the SolidWorks model up into the ERP system. And so our CEO saw this, sent it over, said, hey, take a look at this. And sure enough, that's where you and I started to talk, and we kicked it off from there in terms of getting it set up first for the engineers to use it manually. And then once we got the bugs worked out, just get it moved over to an automated process to where it happens automatically in the background now.
Tell me a little bit about like, obviously the vision was, I think as your owner said, the vision was like anywhere, right? They could just go and have everything done, right? All the models, everything done.
Yeah.
So go ahead, Jonathan.
Yeah, so stepping a little bit further back from where Ethan was, in the 1990s, we had a company called Design Automation Associates create a configurator for us for the Simplicity bearings. And it was hard-coded, it generated the prints, it generated the BOM and the routing on paper. Mm-hmm. Because back in the 90s, it was a more paper-based system. We weren't on the predecessor to Sightline just yet. So we had this really phenomenal system, but unfortunately it was all hard-coded and none of our employees could maintain it. So after about 10 years, we had all kinds of new equipment. Our manufacturing processes were different. We had new variations. So the system that we had was no longer really as usable as it once was, unfortunately. So then early 2000s, my dad and I were talking, and I kind of came up with this idea of we should have, because he was talking about creating and automating the engineering process, because that's what we were used to. And I said, no, that's not what we need to be doing. We need to be looking at automating the entire process, going from customer to the shop floor with no human interaction. And that's kind of where the genesis of this came from. And mid 2000s, we had a brilliant guy working for us as a programmer, and he and I mapped out this configurator, how it's going to work, and he started programming the whole thing. Basically, he started programming what Infor CPQ does, with interactions to Sightline and to SolidWorks, doing all this. And he was about 2 years into the project, and before we decided to have him do that, we actually looked at Infor CPQ as its predecessor's name and some of the other configuration softwares out there. We decided to go this route because none of them would do what we want to do. None of them could take it the entire way. So we got 2 years into this project, and then he left our business with a project that was like 90% done. And he's a great guy. He and I are still friends to this day. He was moving back to Ohio to, be starting a family and all that kind of stuff. So it was the right choice for him. He ended up getting a job with Infor, building their CPQ product, basically because of what he was doing for us. They hired him. But at that point, we decided we were going to use commercial software instead of building everything from scratch as much as we could. And still, there's nothing out there that does everything. Ethan is like the brilliant person here that put this all together. So, I had the brilliant idea and then he made it work. So a lot of credit goes to him here making this work. But the end goal has always been for us to go from a customer on the website, self-servicing them, which of course is like a cost savings to us. But more importantly, as the generations change, and now we have kids coming out of college, and I guess I can say that because my teenagers just pointed out that I'm the old fart that they're making fun of on TikTok now, apparently.
Me too, brother.
But
right there with you,
right,
brother.
Yeah, these young kids have grown up in the Amazon generation, where they can go to their phone, push some buttons, and whatever they want will be delivered to them the same day now, or tomorrow at the worst case. So now we have that self-service, and immediate resolution is worth more than whatever the company's going to save from not having to interact with the humans. Our goal is to try and go from that self-service portal for the customer to give them the immediate solution that they want, and then to go all the way through our factory, all the way out to job packet printing on the floor. My goal is to have absolutely everything automated. The only thing that I haven't figured out yet how to automate, so it'd be like the one interaction that we're still going to allow for a human, would be if someone goes and configures something on our website, and instead of buying it with a credit card order, they turn around and hand it off to, the engineer hands it off to buyer, or to their boss, who then hands it off to a buyer, who hands it off to somebody else, who hands it off to a distributor to then place the order, right? Because there's too many broken links there, other than maybe just the part number that happens to match. So if that does happen, there's a configuration ID that may or may not get passed along in the right field or not. And so we will allow a customer service person to go into the back end of the configurator, basically like link the configuration ID to the Sightline customer order number, and then push a button, and then the rest of it's done. So sometimes there may need to be a very short interaction with somebody in customer service, or if there's an issue with like a credit card not processing properly or something like that. But the normal flow will be to go from the website to a job packet printing on the shop floor with zero human interaction. And we've now proven that we can do that here in 10, 15 minutes of processing time. And primarily it's just whatever the queue time is on the server.
Right.
And, we don't want our servers pushing immediately everything all the way through. It's better to let them queue a little bit. And at the end of the day, 60 seconds versus 15 has absolutely no bearing on our ability to satisfy our customers. So it makes things a lot easier to batch things and process them.
Tell me a little bit about the vision, because you talked about, and we talked about, kind of to your point, like you're going to have a website, right? A front end, and you're utilizing N4, and that's great. And they can get what they want. But your vision was all the way to the shop floor, completely automated. And then CADTALK, of course, we articulated that quite well. Like you have CPQ, and that creates this SolidWorks model that then gets outputted. And then to get into Sightline, that's where CADTALK fits, right? And that's great. But you talked about, like, I think Ethan talked about, like, it took some time to walk through each of that process, right? Because you didn't have everything up front, and it was kind of iterative, right? But you think about the investment you're going to make as a multi-year investment. Stepping back a little bit, what was the driver for you to say, this is where we want to go? Like, that's the vision you want. What did you see for your business that this would be a thing, right? Like, because we're in the automation game, right? We're in the automation conversations all the time. So I'm talking to someone like you who's making those business decisions, and I say, okay, why would you do this? Why would you have that vision? What's it going to help you achieve? And how did you know you were going to realize that benefit?
Yeah. So, we have to remember this is, a good 15, actually this based on my original notes I have in a little red and black book, stocked away somewhere from 2008. We're talking 15 plus years ago, actually 20 years ago, of where the genesis of this was. And if we think about what was on the internet back then,
nothing.
Configurators were just starting to like be a thing, right? And they were really used in two big industries at the time. Cars, where you can go on and kind of begin to select, what you wanted for a car, and computers. And, I'm an engineer by degree, and I'm a big nerd, and I like configuring computers. So, I kind of took that experience as a customer, and I knew that we had a configurator internally for engineering automation, because that's what they were really focused on at the time. And I said, this is where we really want to go. And at that time, and I tried to get a patent on this, and the patent office rejected it because somebody else had some really completely unassociated patent that the patent examiner thought was an exact copy, and it was like nothing like it. But I digress. So I tried to get a patent on a configurator that would actually configure a multi-axis system, is what we were trying to get to, where we started with, where a customer put in their application data. And then, because I had designed a system for a customer, and the first one I did, it took me, someone who knows this industry, it took me over 40 hours to go through and identify our products, to identify the associated products, or accessories, I guess, if you will, right? Because we make the actuators, but we don't make the motors, right? So I had to go and get quotes and spec out a couple different motor options, and then go get pricing from those and find what was most cost effective. And then I do the coupling and the gearbox and the drive shaft, and the cable carriers and the sensors, and a bunch of brackets and all this stuff. And by the time I was all done, it took me over 40 hours. And I'm like, this is painful. If this is what customers are going through, we've got to come up with a faster, better solution to it. So that's where things started with this whole project and process. And we tried looking for some commercial software, but there was nothing out there that did everything we wanted it to do. So we said, okay, let's look for the whatever software we can find that does the biggest piece of it, the biggest bulk of it. And that's where we settled on the Infor CPQ product. It didn't do everything that we wanted it to do, but we figured, okay, let's start with whatever this product does and get as much bang for the buck out of it as we possibly can, right? So we started, and there was a lot of distrust from our engineering team on on how that would work, right? And I'm sitting here saying, the engineers are all like, this machine, this software is never going to know everything I know. Well, from 40 years of doing this and all this stuff, right? Same thing our application engineers say today, and same thing I hear with when I was at the Sun conference talking with people. They're like, oh, our product is too specialized. And they showed me. I'm like, well, show me what you're talking about. I'm like, I looked at the product, and I'm like, that can absolutely be customized. And they're like, well, there's this one-off option where we just did this for a military contractor. I'm like, oh, okay. What % of your business is that? Like, oh, we get 1 or 2 orders like that a year. Like, oh, okay, that's fine. So what we realize over time is we're not looking for the configurator to do everything. We want our configurator to do 90 to 95% is our goal. And then the remaining 5 to 10% of the effort, which actually turns into like 20%, 30% of our overall sales, is things that are customized, right? Because we make standard product that is not a commodity, but it's a single SKU, catalog SKU that we sell. Then we have customizable products. Like a lot of our actuators are available with multiple different leads of screws, multiple different length options. Like we sell it by the millimeter. So if we have an actuator that is, let's say, has 3 different drive options, but you can buy it anywhere from 0 to 6 meters, that's 6,000 variations of a SKU. And then you multiply that by 3 drive options, now you're at 18,000 parts. You add another part, now you're at 30 on the option, now you're at 36,000 parts. And it goes on and on and on and on from there, to the point where, like Ethan mentioned earlier, that little red bearing that looks so simple in our catalog actually has 126,000 possible derivations to it, which is a nightmare to create, but then it's an even bigger nightmare to maintain.
Mm-hmm.
Which I know, we're going to talk about the maintenance side of it, which is kind of an unexpected benefit. We'll talk about that a little bit later on the podcast. But that was a huge upside to us that we didn't initially expect, but it's been wonderful for us.
Which I can speak to that. When I came in and first started, we had the bearing drawings as tabular drawings. So you would take a more or less a generic print, and you'd have a table of dimensions up there. So depending on the option you want, you take that dimension in that table and you substitute it into the print. So if you can think of being an operator at the shop floor and you get a print packet and you have to use basically a decoder ring to figure out what the dimensions are for your print as you're going through manufacturing it. Yeah, we wanted to get away from that. So the first couple of years, and I say a couple of years because, like I said, there's 120,000 options available here. We had decades worth of prints and data that we had to comb through and put into a standardized, uniform method to drive the configurator. So to Jonathan's point, maintaining things now is as easy as opening up basically a spreadsheet, making a change to not just a value, but to an equation to control values. And then everything is updated from that point forward. So you're not just updating one print, you're updating a whole family of prints, depending on your process changes.
We used to have an entire large room in our factory that was filled with nothing but file cabinets. And those file cabinets had the master prints. Whenever we would create a job, production control would go in there, find the master, make a photocopy of it. And not just the prints, but the prints, the BOM, the routing, the inspection sheets, everything that went with it. And then take that back and release that to the shop. That's all gone now.
Right.
We still have a little bit of that left for some really old custom stuff, but even that we've pretty much photocopied now and just have that saved as a PDF for some of our really old parts that we still continue to make occasionally. But everything new is now generated automatically, which a few years ago we were AS certified right before COVID, and then we realized that we didn't really have to go through all of the bureaucratic hurdles of maintaining a registration. We just kept the quality systems in place, and that was good enough for our customers. So we switched away from that, but it was a huge benefit for any company out there that's ISO or AS certified, because every time you generate a new print packet for the shop floor, you're automatically pulling the latest revision.
Yep. And to one of Jonathan's earlier comments, he talked about we want to get it to the 90% of the way mark for custom applications. So one of the unique things that we do with our software, most CPQ softwares, when you buy them, it's a quoting tool at the end of the day. It'll give you a nice price. It'll give you a list of line items, but all the engineering work still has to be done. We set up our system to where when you configure something, even if you want to do something custom, it gets you to that 90% mark. The engineer takes the model, which is an engineered model. They add the features onto there, and they're ready to go. And then they push it up through CADTALK. They don't have to start over from scratch to do something custom. They take what's close enough to the end application, make the modification, and push it up. And the benefit for using CADTALK as well, and a lot of engineers will probably share the same struggle. You'll go into the ERP system, you'll find the closest thing to what you're looking for, copy, paste it, and make your changes. Which when you do that, you're also copying and pasting any of the errors that existed in there. And you continue to do that, and you compound errors. By using CADTALK and just pushing the model straight into the system, we're avoiding that issue. You're creating that new component, brand new into the system, but you're not spending hours doing all of that clerical work. You're using the rules that are in place to do that for you. So it's saving our engineers lots of hours that way.
So just so I understand, like does CPQ actually drive like design tables and SolidWorks to generate the models? Is that how it?
To a point. So CPQ, when we bought it, and this is where Jonathan was talking about the customization of the software, it would generate a model and it would generate a generic drawing. But we added additional functionality into that in programming in order to create that print that looks identical to what an engineer would produce, along with the inspection sheets and those other things. So that's all the development that we did in-house for those first couple of years, is get it to the point where when you're looking at a print packet, you don't know if this came from a person or from a machine. That's the whole goal. Because if we want to grow the business, there's either two ways to scale. You either scale with people or you scale with automation. Well, we know that scaling with people isn't sustainable. So we had to scale with automation, and that's what ultimately drove the decisions we did.
So it looks like, I mean, the configurator would drive the models, and then are you guys using the models for like CAM programming and things like that directly, or just going from just directly to prints and stuff? Okay, so that makes sense. So now you have 3D models, which you can.
Our methodology is it's called MBE, or model-based enterprise. We're working to get to that where your SolidWorks model is your master. It's your master for your drawing. It's your master for your ERP system. It's your master for your CAM system. So you're not creating copies of these and having to make modifications. End of the day, we want the configurator not to drive just the prints, but all the way through to the machines, to where if it's all set up properly, the machine just queues up and starts to produce out the parts that are needed. You don't even need an operator there to press the button anymore. It would just work lights out.
Yeah, I was thinking about it. I was like, like at some point you don't even need the drawings anymore, other than for inspections or something like that, and that's even that. Yeah, it's definitely. I remember talking about this years ago. It's like you guys are really getting closer and closer to that kind of world where, like, because people talk about drawings and print packages, but those are actually still a remnant of a human being involved, to read it. I mean,
yeah, and the prints that we make and our configurator makes, because like when I worked for a Fortune 500 company, design engineering made a finished inspection print, and the engineers are like, I don't care how manufacturing makes it, I just want this part. But for us, we actually do inspection prints and operational prints. So if we make that simplicity bearing, we start off as a bar stock, and that comes in so we have our first operational drawing is an aluminum extrusion bar, right? That's 12 feet long, and that's our raw material print. And then from there we go to op 10 and op 20 and op 30 and op 40, and there's a matching CAD model with all the exact down to 10,000th of an inch dimensions for every single process. And then there's a relevant inspection sheet for every single process, and all that is generated for the shop floor by the system that we're talking about today.
To do that manually would be unbelievable. Nobody would bother to do every step. That's impressive. It's like the inspection of each step, like literally a drawing for each step for the inspection.
It's an exact drawing for each step. And
that's pretty cool.
Sometimes we even have where it's critical, where manufacturing, you put a part on a mill, let's say, and you have to flip from side A to side B. If there's a dimension that has to be inspected midway through the process, we'll have side A print, side B print, side C print, side D print, all the way up through side six sides that need to be machined.
So I'm just thinking through how you would do that, like, because then you'd actually have to know the operations during the configuration stage, right? Like, okay, so because that like that the first operation is to cut on the bar stock, and the next operation is maybe to run to a mill, and what features are being built at each different machine.
Correct.
So all of these is built from templates. So as it's going through, it knows which operations to remove or to add into the system, which drawing views to remove or add in, what layers to hide or unhide, what dimensions to hide or unhide. And it does all of this work for you as it goes through, so that you're producing the print that you need or the part that you need. Now, going back to my comment earlier, it's not just a single page in a print. Like Jonathan said, it's multiple operations. And these used to be multiple tabular print operation sheets. So it's just the layers of complexity of what used to be there is gone now. And it makes it so much easier for the operator to come in and do what they need to do.
How long does it take you to set up a completely new design, like our new product in the configurator?
At this point, it takes us maybe 2 to 3 weeks to get it all set up. And that's working with engineering to make sure that we get the prints in, we get the testing done, we get all the dimensions into the tables that we need. We do the user interface testing. We do the marketing images and catalogs and put those up on there as well, and then set it up with our pricing system as well.
That's actually I was thinking you were going to say months, because like that's but you have a system now.
It used to be months when you had a lot of information that you had to compile. For new product releases, it is months of work for engineering to develop the new product, but actually once they have that product implemented and ready to go, the implementation into the configurator system isn't that long. There's just a decent amount of testing.
Yeah. That's very cool. Yeah. See, like they kind of basically the engineers generate kind of a base model from which then you build the configuration view from that,
they do their base model, they do their environmental testing with all of it, they make sure that it works the way they expect it to work, and once they're ready to go, they go, here's the parts, make the magic work.
And that's fair to mention too, because different companies do things different ways, right? Some companies with like Sightline, nothing goes to the shop floor, nothing leaves the office area unless it's in Sightline, right? But for us to not muck up our system, if you will, can fill it with things that aren't going to be turned into production and aren't going to be maintained long term. We keep all of our R&D outside of Sightline. We keep all of our R&D outside the configurator. So, we do go through this R&D stage where engineering is iterating on the design, sending stuff to our tool room to have prototype parts made, assembling it, testing, and then repeating the process as needed. And then once all of that is done, and then we move out of the R&D stage into the deployment stage, then we get into the point where now Ethan's team, as they're working on the configurator, has a nice, tidy package. And by that time, manufacturing engineering has already been involved, because in our company, we very much believe that design engineering and manufacturing engineering go hand in hand, because depending on which book and which statistic you read, right, a lot of people say that 90% of a cost is engineered in. And by the time the part goes to production, there's only so much that engineers can do to cost reduce the part in the future. Right. So what we want to do is we want to make sure that we have the most efficient process possible up front. And so there's a little bit longer of a cycle that goes there, and things are a little bit neater by the time it gets to the configurator or into when we get ready to put it into Silo.
It's kind of the configure to order process is so interesting. Like I came from an engineer to order when I was in engineering, and it was like, I was a manufacturing engineer industrial engineer is where I came from. And it's just a different, like that in that world, like the manufacturing engineering was like an afterthought. It was like, they were just trying to get the designs done fast enough, Yeah. So whereas like when you're doing something configure to order or make to order, the manufacturing engineering is so more critical, because that's where all the cost is. Like you got to figure out like that during the design stage and things like that. So it's kind of like, we're only going to make one of these, so I don't really care how we manufacture it. It's the optimization problem is different.
And I remember reading when I was in grad school. I remember reading a case study where they talked about one of the reasons why Japanese automotive outperformed U.S. automotive back 20 years ago, and it had to go back to the design process. The American automotive started with a clay model and designed the body and designed the shape, and then engineers had to fit everything into that shape that they were given. In Japan, they started from the frame and worked their way out, and then they made the body look as pretty as they could. So their process, by definition, was a whole lot more efficient than the American process, because they didn't have to make trade-offs on what was the most effective and efficient way to manufacture the car, because they get to put the gas tank where they want to put the gas tank. They get to put the fuel port where they want to put the fuel port. They get to make all those choices on what's the safest, strongest, and most cost-effective option. Whereas a lot of times, American automotive, if you ever gone to a car and like, why is that button there? Well, it's probably not because a human wants to touch it there. It's because that's where they could fit it.
Yeah, because think about every engineering problem starts with what constraints do you apply in the beginning to engineer around, and if you change the constraints, it changes the entire design. And that makes a lot of sense. Huh. I didn't know about that one, about the Japanese versus the American kind of model. But it starts with kind of like, which kind of makes sense, right? It's almost cultural. It's like we want to look a certain way first, and then you got to figure out how the engineering works. Whereas like the other, maybe culturally, you're like, we just need the thing to work, and then if it looks pretty at the end, that's great.
Right.
It just depends on the culture, I guess.
And cars in the 90s don't look like they look like today, right?
No, they don't. That's cool.
So maybe Ethan, you might know, maybe Jonathan, you do know, how long have you had this end-to-end system?
So we got the end-to-end system finalized last year, to where you can go from the configurator all the way through the shop floor. Because again, we put in puzzle pieces as we go. Right. We're not going to build the entire solution all the way through. We're going to get it to the point where it takes care of the biggest need at that time.
Right.
So for the first couple of years developing the configurator, the need was, we got to take some of this work off the shoulders of the engineers. They're drowning in work right now. Because you would have engineers come in, spend their entire day just working on standard product to make the prints to get them out the door, not working on the custom things, the fun things that they want to work on. So right now, and we kind of did a evaluation of the configurator last year, it did the equivalent amount of work as 6 to 8 full-time engineers. So that'd be around $2 million worth of salaries and benefits of what it's just doing in the background. But that enables the engineers to work on new product development, to work on truly custom applications. and not to have to dread coming into work just to work on a bearing that should be standardized and not need to be touched. So the only times we really get in and modify the system is when we have process enhancements and we go, okay, we had a process improvement, or this machine's no longer being used, we're using a better one. How do we improve the process? We make those changes, which no longer take weeks to do because you're no longer touching hundreds of prints. You can do that in an afternoon now.
So a great example of this is a few years ago, we released a new liner for Simplicity bearing called Freelon W. W, it's white. It happens to be an FDA, careful language, certified material for indirect food contact. And, if we would have done that the manual way, taken those 126,000 variations that Ethan mentioned and made this liner available to all of those, even though not all of them are in Sightline already, but there's 15,000 so variations in Sightline. We would have tried to go back and do an engineering change and all of that. It would have been months and months and months of work for our engineering team to go ahead and make that happen. But now we go into the configurator, and a change like that, where we're adding a new feature that's going to be automatically populated, which fortunately for that one, there's not a whole lot of dimensional changes with it. Something like that is, Ethan, what, day?
Maybe a day?
Couple hours worth of work?
Yeah. Most of that is just testing and making sure that you put the change in the right place.
Yeah.
So you're essentially that case though, when it gets generated through the configurator for a particular customer, it's given a unique number at that point because it's basically a new part, right? That way you're not having to do, that's how you're getting away from doing the engineering change, because you're just creating a new thing at that point.
Right. But that's the same thing would apply to if we wanted to make a raw material change and we wanted to, which has happened quite a bit, during COVID times, supply chain, there's been all kinds of supply chain issues that have come through, and we've had to change raw material from one material to another. And maybe it's something minor. You go from 6063 to 6065 T6 aluminum. The material properties are basically the same for our application. It doesn't matter at all. And a change like that would have been terrible to try and make the old way, manual way, but we go into CPQ and make that change, then have CADTALK push it out just immediately. Like Ethan said, a couple hours worth of work, and most of that's just checking.
We had a situation a couple of years back where we had to do a batch change like that to a couple thousand parts. And so we made the updates in the configurator that was ready to go, but then we wrote an automation to where we dumped in a bunch of part numbers. It configured everything automatically, and then it pushed all of them through CADTALK automatically. So that way, thousands of items in our ERP system got updated overnight, as opposed to having to go through that manual where you almost need to have a group of people dedicated to working on this full time to get the change done. It's, all right, give me a few hours, we'll make the change here, we'll run a script to automate it, and it should be ready to go in the morning.
That's interesting. You actually did do it. You used even the same process to do an update on an existing design, like we were just changing out the materials, because it's like form, fit, or function didn't change. You just changed the raw materials, so you had to get the routings updated and stuff like that for the consumption. Mm-hmm. Yeah, that makes sense.
Exactly. In the past, changes like this would have resulted in a lot of red lines until everything is updated.
Yeah.
And still a lot of validation to do. Now we don't have to worry about that process.
Yeah, that's cool. Yeah.
We did
manufacturing engineers are going through a lot less red pens than they used to.
Yeah.
Yeah, I bet.
We did a conversation with Scott, and I had a conversation a few weeks back about supply chains, and about how, of course, it was CADTALK centered, but it was how like an integration can help you deal with supply chain issues where you need to make changes. You guys experienced that like in real life. It's a real life thing, right? What you said was like either through COVID or now people are talking about tariffs or whatever. If things need to be changed, you could actually realize those changes immediately and make the shift.
So I can give you an actual real world example of where that would come through. here, and something that we haven't talked about yet too. Just one more example for you. Now, I'm making this up because our simplicity bearings are made in the USA, so they're not subject to tariffs, right? So let's say we had a product that we were buying and reselling, and we had to account for a new tariff that was coming in on our cost structure. And let's just say it was, again, our simplicity bearings are made in the USA. This doesn't apply to them, right? But let's say that same product or an equivalent product that also had 12,000 SKUs in Sightline needed to have its pricing updated. Well, to go back through and to manually do that in Sightline is kind of painful. There are some tools that allow you to go through and do pricing updates as percentages, but then you don't end up with like nice price numbers, and over time you get this copy and paste effect where all of a sudden things don't line up, and then customers sometimes will quote different options. Or like, well, if I want to add a seal to this bearing, how come it's $5 over here and $6 over here and $3 over here and $20 over here? Well, that's because some human in our company over time made some mistake, like unintentionally, right? But or like you start copying and pasting things. Sometimes you round to the fourth or fifth decimal place, sometimes you don't. And so you get all this kind of fuzzy stuff, right? So now when we do pricing updates, instead of trying to deal with 12,000 SKUs in Sightline, we go back to the configurator, make a change in a spreadsheet, in basically just one spreadsheet. And then like Ethan said, that routine that he wrote will go and recalculate all the prices and then push them to Sightline overnight. And now we have exact uniformity in our pricing. Everything is neat and clean. Everything is explainable. Customers don't have to try and figure out what the pricing is and see if maybe one seal option is less than the other in certain scenarios, because they know exactly what it is. And that alone right there has also saved us a ton of time every time we need to do a pricing update.
And Jonathan had a key word back there, was the explainability of all of this. So because all of our systems are now rule-based, we can go back and explain, this is why that dimension is the way it is. This is why that price structure is the way it is. We had a situation, again, a couple of years back where one of the operators came up and said, hey, I want to change this dimension so it makes it easier for me to manufacture. It's like, all right, let's pull up the rules. If we make this change here, we need to change all of these values as well because it's rule-based driven, and it's going to drive these effects downstream. Are you sure you want to make that change? And then it came to the fact of, well, no, if I make that change, it's going to affect everybody else downstream in a negative impact. In the previous life, we would have just gone, all right, yeah, we can make that change. And it would have taken a lot of time to make the change. We wouldn't have known about the effects until they get downstream, and then we would have had to revert that change. Now we can test it all effectively live and then check it out and then validate whether we want to make that change or not.
And our engineers don't have to play the scavenger hunt game where they go and look for all the derivative products of that parent part. Because if we make the change in the configurator, the parent part gets changed, and so do all the derivative parts.
Yeah, it just gets exponential after a while. It's because by going back, you just keep going back to the original source, which is the rules-based engine that drives everything to do the changes, as opposed to do all the derivatives, which makes a lot. I mean, it's a brilliant solution. It really is.
I mean, and the real effect and our impact on our business is our sustaining engineering department, people that do the ECs, engineering changes, that kind of stuff. Used to be 9-10 people, and now we're down to 2.5.
I believe that. That's because you're essentially automated. I mean, that's
right.
Yeah.
And those 2.5 people get to do other things too. Like they get to do some new product related stuff. So it keeps them entertained, because let's face it, engineering changes is not one of the most joyful things that engineers do on a daily or weekly basis.
No, actually, when I was years ago, I was at Jones. I actually wrote the system that did the engineering changes to automate most of it because I hated it so much. I mean, CADTALK exists because there was a job I hated. I mean, that's exactly what it is. So, so I'm very keen on that. Like, let's get rid of these things that nobody likes to do. So,
right.
So I want to be mindful of time here. This has been great for my understanding as well. And I have a couple more questions, and then we'll let you guys go. I guess first, you guys have had that vision and you've been worked on that whole process. And of course, a lot of what you're advocating here, what we say when we talk to customers, right? Hey, saves you time, rules-based engine, consistency, repeatable processes, supply. We talk about this all the time. And of course, hearing it from you and yourselves and having experienced that, of course, is the best evidence ever. But talk a little bit about, like, I'm a manufacturing company. I'm not even doing CAD integration. I'm not doing integration. We're not even driving our model. I'm not connecting my model to ERP, or I'm not, this conversation might feel overwhelming, right? It's like to them, you PBC Linear is light years ahead. How do you help? Because how do you, as a model, help other customers, right? Think about what they're doing, other manufacturers. To Jonathan, to your point, it's American made. You're an American-based company, and we all know, American manufacturing, right? We know about what happened to that. We also know what it's in the conversation today, right? Politically, regardless of your politics, it's in the conversation, right? So what conversation do you have to other manufacturing companies about, like, what you've done, what you've learned, and how that investment can pay off, and how, you, as an American manufacturer, you can compete, you can do well, all of those things.
Right. Sure. So, I mean, as an American manufacturer, I feel like I'm invested in helping other manufacturers, especially since we sell parts to a lot of them, right? So as long as you're not one of my direct competitors, then there's not a whole lot of them out there. So I'm happy to help. And I try to just let people ask questions, right? Because whether you're on the business side of it or manufacturing side or engineering side, I have background in all those areas, so I can help answer questions, at least intelligently enough that people don't glass over when we start talking. And probably the biggest thing that starts is people are like, oh, my product is too specialized. And while I don't sell CAD software, I don't sell CPQ, I don't sell CADTALK. I'm happy to have the conversations with people about our benefits to them. And I think it probably boils down to is, if your company has a catalog with SKUs in it, your product can be probably benefit from running through some product like CPQ and CADTALK. Okay. If you are a design house where you design assembly equipment and every single project you do is unique, I'm talking like totally unique. Like you're packaging cheese one day and you're packaging electronics another day, and your BOM is completely unique between the two. In that case, then probably not. But even still, if you're designing an assembly line, you could probably save yourself a whole bunch of time if you were to design like an 80/20 or Bosch style or item or whoever's T-slot aluminum extrusion you use. If you were to design modular cells and you just fit equipment inside of each cell, you'd probably save yourself a whole bunch of time by doing that. Even they could benefit from it. But if you make whether you make bicycles or gearboxes or chain, and you sell that product, and you have a configurable SKU in your catalog, a smart part number, your product could benefit from a configurator.
Right.
And then once you get people to buy into that, or even if they buy into it with disbelief, you just open that door to continue the conversation, to let them ask questions. And I try my best just to let people ask whatever question you want. And as long as I'm not giving away a trade secret, I'll answer it. Or let's play pretend and pretend I'm a consultant and you have a product that, you tell me about your product and I'll tell you how I think it could probably be configured.
So other than you, where do they go other than you? Like, who do they talk to, right? Because that's gotta be the biggest question. Like, how do they find that information, right? Who are the people that you would talk to? What resources would you recommend to those companies to begin whatever journey they're on?
Google. That's where we all start today nowadays, right?
I would actually chime in there and say, look at a model-based enterprise and kind of look at how you develop yourself towards that, and more or less a rules-based enterprise. Another resource I would say, and this is kind of giving a word out for my type of people, but find a developer and just hire them in, bring them in, somebody who's keen to automate processes, because you'll be surprised at what they find that they can turn into a rules-based process and automate for your company.
Right. And that's something that's probably real important. One of the key secrets, if you will, to our success, and it's not really a secret, I'm just going to tell you here, is our configuration team is a combination of IT and engineering. Ethan happens to be very, very unique because he started in engineering and has moved over to IT, and he has that natural ability built in. But for a lot of companies, you're going to have two parts. You're going to have the IT side that helps with the automations, help with the programming, maintains the database. Then you have engineering that's going to be in charge of populating the rules. Think about it like a website. You've got a developer who develops all the framework and does all that programming stuff. Then you have the marketing team that loads all the products into it, right? So it's going to be the same thing here. Generally speaking, you're not going to have one person in your company that's going to do the whole thing. The other thing to look at out there is, and there's different types of configuration software out there depending on what you want as a business. There's software out there that will just do the configuring and quoting side of it. There's software out there that will just do really the engineering side of it. And so you have to decide what you want. But just remember that usually you're either the salesperson making that decision for your business or you're the engineering person making that decision for your business, sometimes without regard for the other department, and, really look at it holistically, right? We're privately held. So fortunately, whether things come out of our left pocket or right pocket, it doesn't matter. It's still coming out of our pants one way. You guys get what I'm saying there.
Yep,
Sorry.
get what you're saying. Yeah. I get it.
It's still like coming out of the same budget, right? So we don't get too worried about that. But when I worked for a public company, they were, sales better not spend engineering budget, engineering better not spend sales as budget, right? And then IT was in the middle of it. So try and look at it holistically, because I guarantee after you get into it, even if you're trying to automate engineering, sales is going to be like, oh, I want some of that. I want to be able to automate the sales process. And probably the worst thing that you can do for your business would be to put in two configuration systems, because then they're going to fight each other. If sales has their own thing and engineering has their own thing, then you no longer have one master of truth. So, I would say, try to look at it holistically. And, the reality too, we talked about, complexity and what things work, right? The design automation associates, back in the 90s, right? When we put our system in, and then we looked at having them redo it in the early 2000s. In the early 2000s, they showed me where they designed a grain silo, an entire large grain silo, elevators, automation, weldments, engineering calculations were done. And the most complex project they ever did from a design standpoint was doing the engineering and design automation for an oil platform.
Wow.
So if you can automate design of an oil platform where you put in variables and then it does all of the equipment, like we would consider that like AI today, like AI would do that, right? But that's been around for over 25 years. It just is not very widely discussed. So even if you think your product is too complex, go to Google, find, do some searching and call up the people that sell the software and get a demo.
Right.
Right. And the other thing too would be to make sure it integrates with the systems you already use. So make sure it integrates with your CAD system, make sure it integrates with your ERP. And, beyond that, everything else today pretty much has APIs. So it works, to integrate, but, try and find something maybe that natively works out of the box as best you can with CAD. I would say CAD's more important than ERP, because your ERP these days, everything's SQL and there's APIs. You can push stuff back and forth a lot easier than you can push stuff into SolidWorks. But,
right.
I'm just the guy with the big ideas. Ethan, is that probably pretty accurate?
Yeah, my philosophy is you can automate anything given enough time and coffee. So if you run into an issue, you can figure out a way around it.
Right. Well, thank you really for spending this time with us. It's really valuable. I really enjoyed this conversation. I'd love to do more of these with manufacturing companies to hear about what you're doing and the success you're having. Just any final thoughts before we let you go? Where can people find you in terms of maybe LinkedIn or your website, or any other things you'd have to say before our listeners before we end the podcast today?
Yeah, sure. Both Ethan and I are on LinkedIn, or you can reach out to us via our company's website, www.pbclinear.com. And probably my final thought is, if you're a manufacturer and you're thinking about doing this, you probably should, because your competitor probably did it yesterday.
Right. That's a good point. That's a good point. I mean, the fact that people are thinking about how to achieve these same goals that you guys have achieved, right? And somebody, it's what Amazon did, right? To your point you made earlier, what Amazon did was give you those products faster, and it's solutions like this that help them do it.
Right. And probably, I just realized this, right? But it's probably also now old farts that are making these decisions. And, we have to recognize that we may not necessarily be in tune with the way the kids coming out of college are wanting to work, the way that they are wanting to experience things. And, we could fight it for some amount of time, but if you continue to fight it, then maybe you go work for Blockbuster because they like doing things their way.
Right. Yeah, good point. Well, thank you, Jonathan, and thank you, Ethan, so much. Scott, was an amazing podcast. I really enjoyed it. So
yeah.
So feel free to, folks, subscribe to the Integrate Intelligently podcast. You hook up with Jonathan or Ethan on LinkedIn or visit their website. Of course, you can visit CADTALK.com and learn more about what we do and how we're part of Jonathan and Ethan's success with PBC Linear. Thanks, you guys, very much, and we'll catch you next time.